bullet is 3 grams. And the question is saying what impulse acts on the bullet. So for part A, we're looking for the impulse, or what is known as J. As we all know from mechanics, F equals ma, Newton's second law, and acceleration is nothing but the rate of change of the velocity. Which I could rewrite as d over dt of mv, since the mass is constant and unchanging. If I multiply both sides by dt, I would get f dt equals d mv. And if I can take the integral of both sides, I would arrive at our famous mechanics equation that says that the integral of the change of momentum, which is the change in momentum, which is, by the way, the impulse, is the integral of f dt from t0 to t1. What remains to be evaluated are the bounds of the integral, and since the question clearly says that the force on the bullet is 360 minus 10 to the 7 t squared until the force becomes 0, I can solve for the time to see where that is, where the force becomes 0. So 360 minus 10 to the 7 t squared equals 0. So I said the force equals 0. So 360 equals 10 to the 7 t squared. And if we solve for time here, it's straightforward algebra calculations. And then square root of that. So this becomes 36 times 10 to the minus 6, which turns out to be 6 times 10 to the minus 3 seconds. And so now I can evaluate my integral from 0 to find the impulse. I can evaluate my integral of 360 minus 10 to the 7 t squared from 0 from 0 to 6 times 10 to the minus 3. And this is a fairly straightforward integral, which is 360t minus 10 to the 7 over 3 t cubed from 0 to 6 times 10 to the minus 3. It's clear that at t equals 0, the entire expression vanishes and becomes 0. So the only thing I have to worry about is 6 times 10 to the minus 3. And now I can go ahead and plug in the numbers. 6 times 10 to the minus 3 minus 10 to the 7 divided by 3. This eraser is not very efficient, is it?
To make it big. To make it big. That's okay.
6 times 10 to the minus 3
The stroke back small.
cube. And after everything is said and done, and when you plug this into your calculator, you will get 1.44. So J equals 1.44 kilometers per second. I'm sorry, kilograms meters per second. Because change in momentum, so we'll have the units of momentum, which is mass in kilograms and meters per second for velocity. And now the second part of the question for B is asking for what is the muzzle velocity of the gun, and that seems to be extremely straightforward because the impulse is nothing but the change of momentum, which is the same thing as mv final minus mv initial. And since we are starting from rest, it's safe to claim that vi equals 0 because at some point it was standing still, wasn't moving. Should be an m there. And so now I have mass, so this whole term drops out. Mass times v initial equals change in momentum, which is the impulse, which is j, and therefore, oops, sorry, this is v final, and therefore v final will be the impulse divided by the mass. Already calculated the impulse to be 1.44 kilograms meters per second divided by, the mass is 3 grams. To convert it to kilograms, we multiply it by 10 to the minus 3 kilograms. You can see that the kilograms crosses out, and v final turns out to be I'll just punch this on my calculator here really quick. 480 meters per second. This